Welcome to this second breakout session of MRN. So today we have basically a good session with a lot of participants from Meta, Microsoft, VIV, and Telefonica, and many companies. And I will let people introducing themselves in each session. Sorry. Yep, that's today. So the scope of today, we are going to focus on the QI, KPIs, network quality, content. So basically, all the evolution of the XR capabilities and the impact on the network. So the agenda is quite tight. So we have sessions, firstly keynote from Gayan, who is going to join me right now. We'll have an update on the group, working on QE, QS, on the different framework measurement. Then a presentation from David from Microsoft. And we'll have a panel session in order to discuss with different experts a bit how they see the evolution of the content, the evolution of the network mechanism, and what we will do going forward for the next 3 years. So let's start with the keynote. If you want to join me, Gayan, please.
Thank you. I was coming up in the stage, I looked at a quick glance at my audience, half of you looking at your phone. Please continue, because more you look at your phone and more consumption of data, more business for me. I'm in the digital tower business. Hi, my name is Gayan. I am from eDotco. We are a Malaysia-based tower company. We own and operate 60,000 towers in 8 Asian markets, 5 in Southeast Asia and 3 in South Asia. We process about 170 million customers. 36 cellular customers out there. So that's pretty much who I am. So back to what I was mentioning. The average screen time today is 6 hours and 58 minutes, which means that we successfully, as a human and mankind in this planet, we look at our screen more than we sleep. We sleep only 6.5 hours. In the digital stacks of digital infra players on the top, telecom operators in the middle, and telecom tower companies, fiber companies, data centers and the world. So you have 1,500 exabyte manufactured and sold on the top. And then you have 800 operators who are spectrum based, manufacturing, selling that back to them. And then we have us, we have 5 million telecom towers out there. Now the question I want to ask, and I saw most of the presentation yesterday and day before, hologram, next generation, metaverse and stuff like that. It's more to do with the how part. I think we need to ask a question, who are we building this network? I think how fast it's going to be built and who are going to be built as well. So I'm going to talk about that a little bit. Bit of background of who we are. We are the largest telecom infrastructure company based out of Kuala Lumpur, Malaysia. We manage about 177 cellular customers. In our market, there are 900 million people. 80% of the 900 million people are within 3 to 5 kilometers of our tower. So that's the reach we are in. And we also process roughly about 20 exabytes in our telecom tower network. The globally 1,500 exabyte, our 900 population carry about 100 exabyte. So I'm carrying 20 out of 100 exabytes. So that's the sheer scale we are managing. We do tower, we own towers, small cells, in-building solution, energy, field operation, all in. Simply put, cost to manufacture a GB, half of that is us. That's how we are. And the 5 markets, we are in Southeast Asia, we are into Malaysia, Indonesia, Philippines, we are into Bangladesh, Pakistan, Sri Lanka, and the world. And then we are 6th largest in the world in terms of count. Now I want to talk to you more about what's the next generation we are looking at. If you're looking at our 8 markets, that's on the top. We have about close to 1 billion people out there, and the number going to be the same, pretty much. But I want to take your attention to 2 aspects. The percentage of digital economy is about 16% now, compared to perhaps other markets. That number going to be 2 times over the next 10 years. But then the most important aspect is that the Gen Alpha and Gen Z, this is where those who born after 1996 and 2010, if you don't know these people, they are your children, they are cousins, and these are the children you gave your phone when they were crying. That generation are going to be the consumers who are going to build the network going forward. Taking that into consideration, we are looking at 15 GB a customer a month now, on average in our 8 market, going to be double over the next 5 years, triple over the next 10 years. That translates to 75,000 more towers over the next 5 years and 50,000 more towers 5 years afterwards. That's the sheer scale we're looking at. Now, I want to break this down to whom we are going to build this network. Take your attention to the last 2 columns, which is the Gen Zs, 96 onwards. These are the generation who have a short attention span up to about 7 seconds. These are the ones who crawl TikTok, Instagram faster. These are the generation who build your GB consumption from backwards about 2 GB to 15 GB over the last 4 years. They are the digital citizens. These are the people who are ubiquitously connected. These are the people who want to be socially responsible, and their screen time is about 4 to 6 hours a day. Now, that's not enough. Gen Alpha is my children generation, those who were born after 2010. These are the children of millennials. And these are the people who are born with the phone in their hand. They are going to have mathematics as their key component going forward. And that's the generation, if we were to build a metaverse, 3D internet, the last 2 columns are the one who are going to consume a large part of that. So if you break this down, globally by 2030, roughly about 6 billion out of 10 billion people, about 60% of the people are in these 2 categories, A. B, 80% of the total data traffic will be consumed by them. That's number 2. Then you break it down into number of data consumption. That's 13 GB a customer a month, going to be 214. It's not they are consuming more data. It's their connected devices going to consume more data. Now, you command various apps. There'll be apps talking to each other. At that era, on their command, there'll be sensors, what you wear in your clothes, what you wear in your glasses, and these are the ones going to add into per capita data consumption. The speed requirement is not 100 Gbps, it's 1000 Gbps is the requirement for them, and the 10 millisecond one. So I think we need to narrow down the business proposition. Who are we building this metaverse ready? Yeah. Now, going forward, so who is going to finance this? I would bring this down to a business proposition as a business case. When the technician is going to leave this room, we still have to figure out who's going to fund the triple the capacity. Who's going to build the data centers, who's going to build fiber and the tower and the IP behind that. So today we have this camel hump theory in Asia. This is where the post-COVID gold rush, about 13 to 15 billion worth of money has came into Singapore, Hong Kong, and deployed them in the Southeast Asian markets. Now, we are entering into a phase where there is a high inflation, high interest rate, cost of capital going up, and so forth. The prices are going down. I, as a digital infrastructure party who is canvassing investment into the market, I am looking for what to look forward for next. That is the metaverse, the 3D internet, fueled by the Gen Zs. So I am banking on all of you all in this room. If we can get this right, that 4 billion people, if they can embrace over the next 7 years' time to the metaverse world, that era, and that's the network we are going to build. And that's something we can look forward to bring our valuation up, right? Now, what does that mean to us? Like, what does it require from the network? So there are 800 operators out there, and I manage about 36 of them in 8 Asian markets. You cannot buy hardware-defined network at $30,000 at a $2 cost per GB. It won't work like that. It has to go Open RAN, disaggregated, air fiber, and all that stuff. Over and above, network also need to be dynamic a little bit. Currently, the network is static. People are going around that. Going forward, network nodes will have to be breathed out and breathed in the peak hour, which means that the drones, backpacks, cars also be part of the network. And that's where we have to build that standard as we go forward. So the spectrum is moving from low to high, mid to high. In all our markets, in Indonesia, Philippines, and Malaysia, we are deploying our spectrum in 2600, 2300, 2500. 5G is happening now. And that's not enough. I think we need to develop a dynamic layer as we go forward. So what to look forward to? And I was so excited to see the Ray-Ban glasses. If we can get this right into the cloud, rather than the Ray-Ban connect to your phone into the cloud, and that will be a game changer, and that will be a version where Gen Zs and Gen Alpha are going to embrace. If we hit that into 1 billion customers in Asian markets, that's a game changer for us. Yeah. So for my fellow panelists coming after, I'm going to give a couple of inputs. So what are those key changes going to take place? Maybe potentially you can take these as well. So data is growing. I'm just going to show you all the data consumption happening in our 8 markets. This is pre-COVID, post-COVID, it's actually doubled. I'm not complaining. More data, more tower is required. Capacity is function of 3 things: more spectrum, more antennas in the same tower, or more towers. We have done with our spectrum, more antennas, and now only left with the more towers. Over the last 2 years and 3 years, we have doubled our capacity. So I'm not complaining about that. Question is the middle layer of the 800 operators, can they afford to pay for it? So question number 1. While we are looking at metaverse, we still have underconnected and unconnected. In Asia, there are still about 204 million people not having 4G connectivity. They have 2G or no G, but they don't have 4G data connectivity. That's 204 million people out there. And also we have 3.3 billion people who doesn't have 5G yet. So that need to be fixed out. The underconnected, you do have a coverage, but don't have an 8 Mbps speed. So in our world, we call it underconnected or a dark spot. There are 660 million people at any given point in time don't have that basic 8 Mbps out there. And our millisecond factors are anything between 20 to 30 numbers, nowhere near the standards what you require. Also, we are sunsetting 3G and we are deploying 5G in all our markets. It's not a bigger scale. Over the next 3 to 5 years' time, we'll be probably getting to 80% coverage. My home country, Malaysia, we are getting into 80% 5G coverage by end of this year. We call it ourselves golden digital decade, and 5G is going to be a key principle behind that. And then you also have metaverse-ready networks being built. The last item I want to cover is these dark spots. This is Johor Bahru, Kuala Lumpur, and the world. And in these 8 markets, we have 1.5 million dark spots, which means 500 meter by 500 meter doesn't have minimum 8 Mbps. So any metaverse-ready product cannot be functioning in this area. This is where when you come to school, go to work, go back home, on the road, have dark spots. So that need to be fixed. Network need to be dynamic and disaggregated. And finally, you also have money out there. There are about 13 to 15 billion worth of money has already come into Asia, standing out there looking for a home for their investment, namely tower, small cell, fiber, and data center, and edge computing. So good news and opportunity out there. So with that, I'm going to summarize this conclusion. Yes, Gen Z and Gen Alpha going to be the key catalyst going forward for our metaverse-ready networks. We are going to be great doing that businesses out there. That's the opportunity for us. I don't think this number 3 is a big issue. Technicians, the smart people in the world will solve this open RAN as we go forward, disaggregate, bring the cost per GB down. But I would narrow this down to one item and one item only. Who's going to finance it? Who's going to build this 3x of capacity, where the capital come from, and where the business case out? So in conclusion, I'm going to leave one thought with you, which is, it's not about how part, it's about whom we are building, and define the end by 2030, work backward. Then you can find your answers. You build the network, you make the end customer requirement, network will come afterwards. It's not the other way around. Thank you very much.
Thank you. We have time for some questions, maybe, from the audience. I don't know, any question from anybody? No? Okay.
Good, thank you.
Sorry, I'm going to get some. Okay, so we move to the next presentation, which is basically the update from the working group. I don't know if you want to move all or one by one. You start?
Yes.
Okay.
Good day, everyone. Thanks for attending the last session of the day. That's amazing. The room is quite full. My name is Francois Blouin. I work for Meta. I'm one of the co-lead of this subgroup called the QoS QE measurement framework, and also we have joined forces with the use case team. So over the next 25 minutes, we'll share with you the work that has taken place mostly this year in 2023, and I'll invite three of the speakers and contributors that have been working on this work. As you see, this is a joint effort between T-Mobile, Vodafone, VIAV, and Meta. In terms of agenda, I'll start with a brief introduction and definitions on quality of experience, quality of service. They are two terms that often are mixed up. We'll drill into the 5 steps measurement frameworks that the team has defined. We'll go over the use cases and then wrap up. At the end of this, we hope that everyone will have now clarity on metrics, targets, and how to design systems from the end-to-end perspective. QoE, quality of experience. We're now talking here everything at the end user level, the customers, what they care about, how much they're happy, delighted, or maybe annoyed. So we want to make sure that the end users, they have a different way of expressing themselves. The end users do not necessarily understand bandwidth, speed test, throughput. They care about my sound quality, how good is the video freezing or rebuffering. End user cares about these metrics, MOS, and so on. At the network layer, or quality of service, now we're talking more at the infrastructure. You're talking about delay, packet loss, jitter. And these are 2 different layers, 2 different dimensions. And the challenge now is, how do they correlate to each other? So that's part of the work that we've been looking at this year. The catalyst or the mission of the trigger for this subgroup has started with this lack of common understanding, common definitions of those QoE metrics. So we hope that we'll be able to make the industry, the different partners, both from the content provider side, the communication service provider side, to talk the same language, understand each other. And in terms of the deliverables, we have 4 deliverables. What you'll see in this presentation are some of those in terms of definition of those metrics, the method we have created to define those metrics, and then how do we measure them, and how do we apply them for specific use cases. And hopefully we can all leverage that as a community and ecosystem. The framework that we're proposing, it's a 5 steps top-down approach, starting at the top, step 1 at the user level, at the QoE level. This is basically understanding how the human works, how they expect services quality to be delivered. Step 2, we're going to be looking at the QoS layer, the network infrastructure. What are those important factors that matters? And at step 3 is how do they correlate to each other? And step 4, Chris will talk about how do we measure them. And step 5, Xinli and Ricardo will present the 2 use cases that we decided to work on this year. So first thing first, how do we define metrics? So the trick here is now how do we classify the different applications, the different metrics that matters for a given applications. Applications being a voice applications, a video application, a gaming applications, they have different aspects that we need to look at. So we typically want to define them into 3 main categories of metrics, the human, system, and context. At the human layer or the human aspect, now we need to understand how the brain works from a visual system, audible systems, touching, etc. So understanding that, immersion. Could I immerse myself for 3D applications? System related or more, maybe perhaps more familiar to us, has to do with the fidelity. Is this image look good? Is it sound good? this response time, responsivity of the system adequate for me? Do I see my feedback coming up? Does my video, when I swipe, the new video is there playing? And the context matters as well, depending on if you're at home on a gigabit internet, on a mobile phone. So the trick now is, how do you build a perceptual model that incorporate these factors? And these factors are here. And there will be a quiz at the end for how many you can remember. In the ideal world, we would be able to monitor, measure, quantify all of them. In reality, it's very difficult. So the question now is, which one do you pick? And we've done research on mostly academic and industry standards to define or identify the ones that matters the most. And in this table here, we've kind of started to compile them, again, categorize them by the type of applications, from voice, video applications, gaming applications, augmented reality applications. And if you look at one of them, let's say the video one, you're going to see some of the most important metrics, like the temporal aspect of video. Am I moving fast enough, or I'm frozen? Spatial compression artifacts. And then what matters most is, as you see, is as you go to immersive applications, you have more and more metrics to monitor. One thing that is important on the QoS level, now I'm done at this infrastructure layer, is although we have to look at end-to-end, we need to design the system from the network perspective and understand how these impairments matters. And the trick part is some are controlled by the content providers, some are controlled by the operators, but you need to understand how each of those actors are controlling them. In terms of relationships between QoE and QoS, there are a number of standards that exist. Again, I will not have time to cover that today. We typically want to go with an objective model as opposed to a subjective model. Reference being a full reference, meaning that you have the source of the video, for example, and you have the delivered video, and you compare them. That's easy, but that's difficult for an operator that is sitting in between that doesn't have access. So no reference models are the one that we're recommending to develop. An example of a parametric model here where you modify the network QoS layer and you're impacting the QoE. This is a voice quality model. Another model from Nokia that is quite interesting and simple here. You can look at the paper, it's quite good. And if we look at all the industry publications, standards, we kind of group them into the left side, the green side, are video models that looks after the video quality, the image quality. On the right side, you're looking at the timeliness. Though, does the system respond fast? If I swipe my video, does the video start? Now the industry is lacking a bit of one model that does everything. I've listed here some of the reference that we found to be interesting and appropriate, and the QoS factors that we believe matters. So to close on the step 3, which is that relationship, is we're proposing two efforts for TIP to continue. One is to align on a no reference metric for video quality, so such as both the operators and the content providers can talk the same language, have the same kind of metrics. We would like also to explore the possibility of, as a content provider, we do have access to the source video, for example. What if we were to expose some of the quality of experience and use a full reference as a more higher precision quality factor? I'll pass it to Chris Murphy here to discuss the step 4, the measurement.
Thank you, Francois. So I'm Chris Murphy from VRV Solutions. So I have some experience, and VRV has a lot of experience in the measurements that we can take of the network and the different places in the network, and how this maps to the quality of service that Francois has been describing just now. So I want to just take a step back and look at the network. This is written as a wireless network, as a cellular network. We're not just limiting ourselves in metaverse networks to cellular networks, but it gives us a way to think about how we measure today various aspects of quality of service in a network. And there are types of measurements which are based on probes. We can probe a connection, a physical connection, which might comprise data for multiple users. So that's one way of making quality of service measurements. We can make flow measurements on particular connections relating to particular subscribers. We can have coordinated measurements between two different parts of the network to measure for example, the delay, the latency, the jitter between those two parts of the network. We can make measurements on the radio side, either aggregated what's the overall performance for a particular radio, particular cell in the cellular network, or even on the per subscriber within the cellular network. And we can make measurements in at the application, either at maybe the mobile device, whatever application is being run there. If it's a metaverse application, it can make measurements. And likewise, in the application server in the cloud, that's able to make measurements. So that there are places we can make measurements in the network in principle. We don't always have access to these places. And there are different types of measurements, the quality of service measurements that Francois took us through before. So how does this relate to metaverse services? So I want to pivot from a network-centric view of these measurements to the metaverse-centric view, the metaverse service. So I wanted to try and create an architecture that was abstract enough that we can map arbitrary metaverse services onto it, and then say, well, what are the things that we can measure? And you might take the view. You might say, well, I'm going to have a metaverse service. It's going to require some hardware, maybe some goggles, maybe something that creates sound. Whatever I've got, then that can make measurements. That can make measurements of the throughput that I've achieved, maybe the latency and the jitter. So why do I care about the network? Well, if you want to know if you've achieved the quality of service that is required to deliver the quality of experience using the models that Francois introduced us to, you can probably do quite a lot with the endpoints. But it's not just about measuring whether we are achieving those quality of service measures. There are other use cases. There are other cases we're interested in. So, for example, you might have a network which is experiencing problems. Maybe you've got some service level agreements and the service level agreements are not being made. How do you troubleshoot that? If the end-to-end network is not delivering, then we need to understand why is it not delivering, where are the problems, where are the pinch points, and how do I solve it? That requires a bit more insight into the network, into the end-to-end network, not just a yes or no, am I delivering the SLAs? Likewise, I might have a network where I want to know as an operator, can I deliver a metaverse service? Is the network able to deliver the SLAs, the quality of service required to deliver the quality of experience? So these need more insight than just measurements at the endpoints. So what I've done here is I've abstracted, I've got an abstract architecture. We don't know yet whether this is going to be sufficient to map every metaverse service that we can possibly think of onto, but it's a start. And what I've done is I've taken the quality of service measurements that Francois introduced us to, and is going to test you on later, onto this architecture. And so what you can see here is the different places where we can measure these different aspects of quality of service. Now, Francois gave us the clarion call to the industry for the QoS, the QoE. How do we build these parametric models that we can use to answer these questions? I think the key here is that what we still don't have is solutions that will be able to resolve impairments in the connectivity that are more granular, because tiny glitches in the network are going to have more impact. A slight delay here and a slight delay there today doesn't typically affect our services that much, but as the services become more immersive, richer, higher bandwidth, then smaller glitches, more temporarily isolated glitches are going to become more impactful, and we have to be able to resolve those because we have to know that they're there and whether we're contravening our SLAs. So we need a measurement infrastructure which is more granular spatially as well as temporally. So this is, in summary, this is a very quick introduction to the actual practicalities of making these measurements of these quality of service. There's still work to do, as I said, but it's a step in the direction. So I think that's the last one. So I'm going to hand over to the step 5. Here's Xinli.
Thank you, Chris. So I'm Xinli from Meta, and I'm working TIP MRN PG use case and QS requirement subgroup. The subgroup is really to work on the QE matrix definition and QS requirements on the end-to-end connectivity for the selected use case. And you come here this afternoon for the last session for metaverse-ready network project session. And you probably want to ask, the use case that I am going to present is short-form video. Is short-form video a metaverse use case? No, it is not. But then you probably want to ask, why the hell that you're going to talk about short-form video? The reason really being that if you look at Ericsson's mobility report as an example, where more than 20% of the traffic nowadays on mobile network is actually generated by short-form video. Short-form video becomes the single most important driver that drives the network evolution. And we believe that the metaverse is evolution, not only at the application level, but it provides requirements on the network to evolve. So when we are looking into our vision of metaverse in the future, we should probably start from where we are today, see how the network is going to evolve. That's the reason we start to look at the short-form video. And then your next question could be, what is a short-form video? What makes it different? Well, in simple words, short-form video basically is a video application, it's a video streaming. But it has its own characteristics, make it different from the other long-form video streaming, like what you mostly would do watching Netflix video at home. What makes it different is typically it's a short. It's typically maybe 30, 40 seconds long, even though the service providers nowadays are allowing longer videos to be classified as short-form video, but the most popular contents are short. The second characteristic is that it's generated by users. It's shared by social media. Before it's published, it may be enhanced with some features, but it's basically produced non-professionally. How to manage the quality of this kind of video would be different from Netflix professionally produced videos. That's another difference that makes short-form video different. And then if you think of normal video streaming, basic contents will be delivered on the request of user. But in short-form video, like Reels, like TikTok, the contents are pushed to the user based on recommendations of some superpower AI machine learning algorithm behind you. That means that it's very important to make it accurate so that the network is used to deliver the effective contents rather than something user doesn't need, doesn't want. And the user behavior in this kind of application also differs. It's like users tend to quickly scroll through the different contents, and then they will stop somewhere, maybe watch for another 3 seconds, decide if they will continue or they will continue to scroll down. And this reminds me, maybe some 20, 30 years ago, when I entered the industry, we were talking about broadband TV or IPTV experiences at the time. It's like zapping between the channels. You really want to have that experience the same as you would do for your cable TV. And here, when you scroll down the short-form video Reels application, you want to hit the button, you want to see the response. Those characteristics of short-form video make the experience definition, makes the quality of service requirements on the network differ from the traditional long-form video streaming. For example, you really have to be timely response to the user request, and the quality of the video has to be controlled such that, yes, user has the expectation, it's non-professional, but still it has to meet certain quality requirements. And with this, by applying the framework developed in the project group, we look at the audio quality, we look at the timeliness, temporary quality of the video, spatial quality of the video, and the context and human factors. Those are the framework presented by Francois. We apply this, and so far, all the mathematics and science. And what we're hoping is really to use some plain English to describe this matrix. For example, if we start with audio quality, the audio mass measured by VQual, this is one of the way to measure audio quality that's been widely adopted. Or you could look at the bitrate or codec type to decide audio quality. And timeliness comes to, people tend to say click to play time. And then also the play success rate is a different way to define click to play, because once you click and it has to be played, say within 1 second or 2 seconds. So this could be another matrix to estimate user experience. And also stalls. You don't want, when you are watching, the picture freeze, right? Number of stalls during your watching during the session would be another very important parameter or matrix for timeliness. Temporal quality would be talking about fluidity, synchronicity, and then we have the spatial quality, video fidelity. All those have different ways to measure in either the client side or in the network or on the server side, so that we get the quality of the video. As Francois mentioned, that there are a lot of work has been done for reference-based video quality estimation, but in our case, for the short-form video, non-reference-based would probably be even more important. But here, it represents a trade-off between the accuracy of the estimate with the complexity of the algorithm, and there are a lot of work to be done there. When it comes to context, is that when we determine the quality of experience, you really want to know if user is on the move or is in the Wi-Fi environment, in the cellular network environment, all that. So those are the factors. Last but not least, it's been debated whether or not this is a good human factor to be considered in evaluating QE. That is the rating of users at the end. Normally, what we observe is that users tend to rate an application when it's a bad experience. If they are happy, they will just go. And so whether this would give us some clear guidance or how we can use that feedback. But those are the QE metrics that are discussed, and we're working on it. And this work in progress, and we would like to invite you to join us and continue to finalize, build agreement, consensus among content providers, operators, so that we can all agree. These are the set of quality of experience metrics that we can use. And so with this, I hand over to Ricardo for the next use case.
Thank you, Xinli. All right, so I'm going to present you this second use case from the subgroup, this volumetric video use case based on telepresence. The idea of this subgroup is to bring, of course, this use case based on volumetric video as a new way to develop the frameworks on this QE. So we have focused on these critical 4 points, which might be basically develop the full body, so bring the full body holograms to the services delivery. Bring also the physical space to it, and of course to have enough angles of freedom and to have freedom of movements, and finally to bring some kind of real-time engagement. So these are the most important points that are brought here in this use case, right? So moving forward, the idea we have here, it's maybe someday to substitute the current method we have for meetings, as for example could be Microsoft Teams or someone, or Google Meet or whatever you can imagine, with some kind of telepresence, with these telepresence ideas. So in order to do this, it is important also to have quite of be flexible with the technology. You maybe can start in a more simple way, not needing a full range of cameras around a conference room, but have maybe a couple of them on both sizes. So, because this technology needs to start and as it is starting, needs to be quite affordable, right? The rest of the points could be kind of integrate computer vision techniques in order to accomplish a more realism in the images. So moving to this slide, the idea on this group is to have enough measurements regarding the volumetric video techniques that can be identified in the human level of satisfaction or immersion capability. So although this subgroup may focus on those QoE features that are measurable regarding volumetric video, also that are measured through volumetric video, but also delivered through the existing systems. This subgroup is going to be taking account also those that are all the relevant quality of experience feature. So regarding to this, it is important to take into account more or less these influencing factors. So the spatial area, the spatial audio, it is important as it give more immersion and can help with the communication each other's. The temporary quality is necessary for example, not only take care of the comfortable of the tools, but also with kind of a healthy environment. And also a spatial quality, it's important as the 3D representation in this telepresence use case would be really taken into account. So the rest of them, responsivity, context, and human factors are also important, but I have not time to explain it all here. And finally, this is a proposed architecture. The idea is to have this initial system to capture all the frameworks and all the metrics to be delivered maybe through the 5G network and be after processes after decompression in a telco edge, for instance, or either can be done on a more dedicated server inside of the price, like more indeed. So basically, this is all I bring here today. I think, Francois, you can come to make the conclusions.
Thank you. Okay, to conclude this talk, basically, as we said, the end user experience is critical to ensure new products' success. stories, so we need to understand those user needs. We are also recommending an end-to-end design approach. That's what the 5 steps top-down approach is addressing. We also hear that some of those new immersive services are not as well known, so there is more work to do in understanding, defining those metrics. And in terms of deliverables for the subgroup, we want to publish this framework and document it, get it approved by TIP. And we would like to explore the possibility of launching another subgroup to look at collaborations between the content providers and the service providers to exchange informations related to quality of experience. So we'll stop here and I'll open the floor for questions.
Any questions? Well, I have a couple. Matus.
Yeah, amazing presentation and great work. Thank you for all these details. I would be just curious about how long are you working on this, and where you think are the biggest challenges in the measurements and the metrics, defining the frameworks, all these things. Thank you.
Do you have an easier question? How long you think we'll be done, or how long have we been working on this? We started this year in 2023, so this is, 10 months of work. We hope to wrap up this in Q1 and Q2 next year. Chris, do you want to give us a framework for the measurement? Is Q1, Q2 next year reasonable, or do I put you?
We have to test the architecture, make sure that's. Yeah, we have to test the architecture, make sure that that's appropriate, suitable for what we intend it to do, and be more specific about the changes that are needed in the ability to measure the networks in order to resolve where the problems are, why we're not meeting SLAs, or why a network would have to be upgraded to support the metaverse services. So Q1, Q2, we will make a lot of progress by then, maybe not completely finish it.
But we hope to have the framework part finished with hopefully a number of metrics defined and so on.
I have a question to Chris. Because we are talking about huge amount of bandwidth with the new application. Are you planning to scale with your testing tool and architecture?
Well, scaling, collecting a huge amount of testing data is one way to do it. The other way to do it is think about it differently. Maybe we don't need to centralize all that data. Maybe we need to be spotting anomalies or recognizing conditions with machine learning models, for example, so that we can do it more intelligently and not have to centralize all the data for the analytics, but have distributed approach to the visibility of the network, or at least more than we are currently. So we need to do things differently. We can't centralize all that data.
Yeah. Is it going to be part of it also of the recommendation? Could be a good one, right? To say, look, to achieve this kind of output, we need to architect the testing environment that way.
I would hope to be able to go into quite a lot of detail on that in our report, yes.
It's good. Xinli, question.
It was not really a question, but I want to go back to what Matish's question there. Even though the subgroup in TIP has started work on this earlier this year in spring after MWC, but actually a lot of work that we're doing here were based on industry work, SDO work, so that we are inheriting a lot of results from the industry research community. And you were also asking what's the challenge. To answer that question, I see the challenge, which is also the opportunity why we take on this journey, is really that the telecom industry and the tech companies like Meta and others, it's a two different worlds. We talk different language about the same thing. And the goal of this group is really to work together to bridge the gaps so that eventually, when it comes to quality of experience, we talk about the same thing. Not use QS of the network as such to replace the user perception of how good a application could be. I think that is the challenge, but that's also why we started work on this. Thank you.
Okay, and last question to Francois.
Oh, there is another question?
No, it's just, I think it's just, there's a question in the audience, or, sorry.
I just have a question about how you guys have thought about consumer privacy and some of the implications and the appropriate aggregation level of the data. Just understanding that, you know, there's different kind of regulatory schemes around the world that might impact the ability to communicate between the two parties. I don't know if you guys have come across that or thought about it.
We haven't looked yet into the privacy. That's a very good question. We typically anonymize data, so I think that will be the short answer to that. Are you talking about if we start exchanging quality of experience data, for example, between carriers and content providers?
Yeah, I mean, just the level of granularity will impact the ability to make the choices, right? And so you can identify even with, you know, a certain level of aggregation. And so if there's any geographic information or where it is on the network relative to where the user is, it's pretty easy to identify. So I'm just curious on how you calibrate kind of that equation to make sure that data matches up.
We have strict policies for anonymizing data. So is it the X number of users? And I think at this point, we were not planning to exchange personal information. We were planning to exchange, is this application performing well in this area, and so on. So it was more of that nature, not to exchange any other personal. It was not PID information.
If I can add on one thing, at least from Meta point of view, it's not only about that at the data level that we don't expose any personal identifiable information, but also that from the way of working, we actually take privacy into account from the very beginning of any work that we do. Applies to here, at least when we are joining the discussion, we make sure all the partners know we don't talk about any particular information about any specific user. We talk about analytics of an application point of view, how this application would be perceived by the users, not by a user, the user, but by users. So that's the way we handle this, and hopefully we will be able to provide aggregated and anonymized analytics of the application's experience for the community. Hope that answers your question.
Yeah. Okay. More questions from Manuel?
Hi.
Sorry.
Impressive journey and great results. So what this room, what those people that are here can help you accelerate what you are doing?
Can you say it louder? I didn't.
So what we can do, the people that are here today listening to you, to help you accelerate this journey and what you are doing?
I think one of the deliverables, good questions, Emmanuel, is to have collaborations between the different actors in the ecosystems and agreed upon those metrics. And the goal is that when the different providers, we can speak the same language and have a common set of metrics and measurement framework points. So the wish list here is to bring the participants, both from operators, content providers, to sit at the same table and have this kind of discussion together. That would be my wish list.
If I can add something, I think we need to move to some practical testing and come with some real testing data, because we have built the framework, the way to do it.
Yes.
So now we need to start testing with friendly users, not going into this.
Yes, having a proof of concept, a trial would certainly.
I think that would be the natural next steps. To
okay, we'll talk next week.
Towards this. Yeah. So.
Okay.
Good.
Okay.
So I think it was a good session. So a lot of work done. since yesterday, the group today. And we have a presentation from David now. Okay, so David, if you want to join us and present yourself, thank you.
Thank you, Alex. Well, thank you. A pleasure to be here. So my role, so I work in Microsoft, David Carmona, I'm VP for Strategic Incubation. So I'm here representing, I think, the cloud side of this, right? So, and it is quite interesting. I would say being a sign, right, that we're coming together here, network and cloud, because as I hope to elaborate more today, the combination of the two is really what is going to enable this new kind of experience, right? So that's the goal that I have today. And if you look back a little bit on the last 2 decades, BC 2 decades on the cloud side for sure, right? So you look back at what has happened in those 20 past years is how the cloud has, in a sense, democratized the access to compute, right? That's the foundation of it, right? Started the foundational, right? So things like the core capabilities of computing, like VMs, then started to go up, right? So things like platform as a service. It moved to more advanced workloads like data, like insights. Now the most recent one, of course, artificial intelligence. So clearly, and in the future, we will continue to go in that direction. Quantum computing, right? So these new types of compute power that are now accessible to any developer, right? And not only in an easy way, but also in a faster way, so that innovation can come faster to those developers. So when you look at the future of the cloud, the reality is that that is not going to be enough moving forward. So the cloud by itself, without combining it with the future of networking, is not going to be able to support these new workloads that we're seeing in the future, like, for example, XR. So it is the combination of those two. It is the combination of networking, future of networking, and future of compute in one unified pane. That is what will enable these experiences, right? So that is a clear realization. And it's not like suddenly Microsoft is going to turn into an operator and is going to start creating this future of networking. No. The idea is how we work together, operators and cloud, so we can provide these experiences to developers, not only to get access to the compute, but also to the networking underneath, right? And when you go a little bit deeper in here, so the 3 key things to keep in mind is, first, just like you go now to the cloud, right? So you go to the cloud, you click next, 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 and you have access to very powerful APIs, like, I don't know, deploying the latest LLM model and getting access to the power of that model in just a few clicks. What is the equivalent for that on the network side? How, as a developer, can I get access to the latest capabilities of the network? Without that, there's no way that developer will be able to create these new experiences. And the whole point behind it is how we need to work together on exposing those network APIs as new services in the cloud. So just like I can get used to the compute capabilities of the cloud, how can I also, as a developer, get access to the APIs? A lot of work in the last year since the announcement of Open Gateway and the previous work on the Camara work group on how we come together as an industry on providing a single interface for developers to get access to those network APIs. But then underneath that, I mean, every time that I saw those beautiful architecture diagrams, right? So these are complex architectures that we need to create to enable these experiences on the network side. So the network itself will be able to be modernized with these new workloads in the cloud, right? And the most obvious one is applying AI to it. So we were mentioning just a second ago, what do we do with all this data for quality of service or quality of experience? What are we going to do with that? Are we going to manually look at that? Are we going to look at that dashboard? This is way more complex than that, right? So we need intelligent insight provided by AI, so we can have not only a clear understanding of what are the anomalies in my network, but also as an opportunity to open new opportunities in my network, right? So our recent work that we have done with 3UK, so the operator in the UK, is how they can use AI to identify what is the gaming experience in the network, and then beyond that, how they can optimize that so they can create a new market for gamers in the UK. So that's the power of AI applied to that. And then, of course, behind that, and we saw a little bit of that in the first segment today, is how the cloud itself can become a platform for the network, right? So how you can start moving network functions to the hybrid cloud. Not that you are going to turn immediately all your network functions to the public cloud. That is not going to happen, especially because you are not going to get the requirements that you are going to need, right? But turning into a hybrid cloud where you have the best of both worlds, super important, so you can have that dynamic network capabilities that we were mentioning at the beginning. So what is the developer experience of that? So being a developer is harder than ever, right? So think of the complexity that we have now to create what we call a modern connected application. So any application like some of the use cases we saw today, right? So those days of creating a network, what I can forget about or creating an application, where I can forget where my application is going to run and over what network my application is going to be connected through, those are long gone. There's no way that you can create these modern experiences without getting access to those capabilities, right? And that is on one side because the compute capabilities, the compute targets are more and more complex and more diverse, right? So you have the private make, you have the public make, you have on-premise, you have the full cloud, you have even space, right? So all this complexity adds a lot to the developer. And then on the other side, you have a very diverse network connectivity. So we are moving more and more to a very disparate, to a very heterogeneous network connectivity that developer will need to create, will need to get access to. So at the end, the vision in here is how we can provide all of this into one unified interface so developers can abstract over the complexity of the target and the network that they will use to do that, right? And then the core things that you see in there, the three things that you have to keep in mind for all of this is first, how can I get access to the network intelligence? How can I get access to the capabilities of, for example, quality of service, both from the information point of view, but also from the control point of view? How can I impact on that quality of service if I'm a developer and I'm creating one of these experiences? The second one is really that concept of unified connectivity is no matter what I'm using, I want a single interface. So if you think about the experiences that a developer has to go through now to create an application that is network aware, that can understand the network that is beneath them and getting access to the capabilities of it, you will need to create an app for every network and every operator in the planet. That is not something that we can ask developers. So you cannot ask a developer to do that. That's why we don't have that many applications that use that today, right? So we need to abstract all of that and unify it across the industry and making sure that developers can get access to those capabilities in a unified way. And then on top of that, of course, is abstracting all of that. So developers, we are used to SDKs. We are used to things that can abstract us from the complexity of the inner works, in this case, of the network. So that's some additional work that we have to do in the industry to make it happen, right? So in our case, so this is our approach in Microsoft. So we announced this in the last Mobile World Congress in Barcelona. In a sense, you can look at it as exposing those APIs in our cloud, in Azure. We call it Azure Programmable Connectivity. And it's just, you can look at it as an aggregator service in Azure where a developer can get access inside the same experience that they have now to the network capabilities. And we can go in more detail on what network capabilities are, right? So this is all based, so you see some of the basic building blocks in there, but of course we provide that unified experience across operators, so you don't need a different, for example, billing, a different sign-in, a different authentication, a different API format for every operator that you are targeting. That unified abstraction with services on top of that, and then the developer tooling and support, right? All of this is based on the work that was announced in the last Mobile World Congress with the Open Gateway, led by GCMA, so we're part of that. We're also founding members of the Camara working group there. And the idea here, as you see, is how we can come together as an industry across all the operators so we can provide that experience to developers. That's the goal for it, right? And so when you look at the detail behind this, so, and I won't go into a lot of detailing here, but you can expect that these APIs are gonna be exposing to developers those core network capabilities that they will need to create these modern connected applications, right? So things like, basic things like credential management, things like discovering resources. So how can I discover edge targets around me so I can distribute my compute efficiently depending on the workload that I'm doing? How can I configure those resources? How can I get access to the quality of service? How can I control the experience that I get on the network? And then finally, how do I monitor that? How do I get the information that I need? For example, those metrics that we saw before, wouldn't it be great if the application itself can control those metrics and can query the network on whether they are meeting their expectations and whether they need to adapt the experience depending on those metrics, right? So let me show you just one example of one company. This is one of the many examples that we can talk today, but there's definitely an emerging pattern in the industry, in the software development industry, where we'll see many applications like this, right? XR, interactive experiences, real-time experiences, those will become more and more popular, right? So this is a company called Halo.car. So this company is based in Vegas, and what they do is an electric car rental service. So you call and you rent a car, right? What is it different about this company is that you get the car at your door like that, right? So no driver on it. So you are at your home and you get the car coming to you, the rental car. It is not autonomous driving, it is remote driving though. So they have a pool of drivers on their offices and they can drive the car to you directly on the door. Very popular service that can be done today. So as you can imagine, creating an application like this is not just relying on your normal internet connectivity. So if you don't have the quality of service that you require, you can crash a car, right? So not something that you want to do. So you need a type of control. In their case, for example, you see in there is that they are able to adapt, depending on the traffic conditions, they are able to adapt the bandwidth that the application can request to the network, right? So this is using 5G, network slicing, etc., so they can get access to that capability of the network. We're going to see this more and more. This application, for example, was done, again, using this unified layer, so they don't have to create one integration for every operator in the industry. They can create these applications across the industry. So just to wrap it up, so think about the opportunity that we have ahead of us, right? So this combination, this convergence between the cloud and network, right? That is an amazing opportunity that we have as an industry. So there are many studies that you can see here, many research of the business opportunity in terms of market growth. But at the end of the day, and you have there one done by TSL, but if you, STL, sorry, but the key message here is the things that we don't even know yet, right? So the new application types that we will be able to power because of this confluence between the cloud and network. So I'm going to stop here so we can have some time for questions. I think we can have a couple of minutes of questions. And then I think, Alex, we have the panel, right? Yeah. Okay. Thank you.
It's really good, so important, the network APIs. So any questions to David? I think it was a very good use cases and capabilities described. Matus.
Thank you, David. And I have just a quick question. Of course, we are working also with you already with the network APIs and several telcos, but I would be interested, how many telcos till now already started to work together with you on these network APIs as a common interface?
Yeah, a lot. So it depends on the stage, right? So those that you have seen that I put there, those are the public references that we announced in the latest wave of network APIs, and we're working super closely with them on defining. This is a little bit defining the APIs as you are developing them, right? So that's the work that we're in the middle of it right now, right? So there's intense work on the Camara work, there's intense work on the Open Gateway initiative, so we can get all together, not only in the technology complexity of doing this, but also things like the business model, the billing, things like those that are equally important, right? So that's the work that we're doing with them. At the same time, we're already scaling to other operators who are joining. We're seeing tremendous interest, of course, in the industry, because it really, I mean, it's a win-win, right? So it's a new market opportunity for operators who can now monetize their investments on networks, right? With these additional services that they can offer to applications like this, right? But at the same time, it's also a way for them to enable new scenarios that can target new use cases.
Thanks for the presentation. I'm curious on now Microsoft is becoming the aggregator, abstractor of the telecom network. So if I request for hello.car a particular quality of a service and I don't get it, who is accountable for the degradations or the lack of not fulfilling my SLA? Is it Microsoft
Yeah, good
or?
point. Yeah, so as I said at the beginning, we are not getting into the telco industry, right? So we are not acquiring any spectrum. We are not hiring the services of the cell towers, right, to build that infrastructure. So when you go to this experience, actually, you have an SLA and an agreement, a user agreement with the operator, right? Then you have, of course, our user agreement for getting access to these APIs. So you can see there is a combination in there, a dual combination of first providing, exposing those APIs, and then the services of the network. No, actually, the experience itself is something that we put a lot of attention, right? So just like any other, you can look at it in any other workload that we expose in our cloud, where we do have strong SLAs on the experience itself, not, of course, on the back end of those providers who are giving those services.
Usually they complain to the operator, but we are used to that, right? We are going to start with a panel because we are a bit short now. Yeah, maybe your last question. Sorry.
Hello. Hi. I see that tend to be two different types of requests from the developers on the capabilities of the network. One is typically to get information from the network, and the other one is more to act on the network. Of those two, I would say, main categories, which one are you seeing as most demanded by the developers? Which kind of those two features are they demanding more now?
Yeah, very good question. So this chart that I put in there actually has that information in more detail. So hopefully we can share the slide after this. It's coming from this research that I was mentioning, STL, where they go API by API and they provide an estimation on the market opportunity. So like all up, if I had to summarize it, consider like 50%, almost 50% of the revenue opportunity coming from quality of service APIs. And those are basically three types, right? So one, half of it is information, so querying about the quality of service. So you do the math, and that's like probably 20-25% of the market opportunity. It's actually understanding what is your quality of service. Then on top of that, you have like less than 25% of that. So the next big thing is actually acting on it, so is the control on the quality of service, and then the rest is resource discovery, so edge discovery. So those three things is almost 50% of the opportunity. Then the next big one after that has to do more with things like device and user authentication. So think of the scenarios that you already have available in a lot of networks where you can query for the device status, right? Or you can query for the authentication of that cell phone user, right? So those have a huge impact on areas like online banking, like payments, like points of sales, right? That's the next big one, and can be like, so from the rest of the pie, I would say like probably 25-30% of the pie. Then the rest of it, which is a little bit more the long tail, are more specialized niche but high value services. One, for example, that we see a lot of potential is location, right? Location, which could be either non-GPS location or highly precise location providers, right? So those are in our insights and opinion, the three big areas that this will open.
Thank you. So I'm sorry we have to move to the panel now. I will ask the panelists to join me. Thanks a lot, David.
Perfect.
And you stay here.
Where do you want me to sit?
Yeah, wherever you want. So today is a good opportunity. We have all the specialists from the MRN have basically an open discussion on how we see things, right? So I will let firstly people to introduce themselves.
Hello. Yeah, this is David Moro from Telefónica. I'm head of service platforms.
Andy Furnell from Meta. I work in network infrastructure, and my core area of focus is informational network interfaces and opportunities they bring to improve quality of experience.
Hi everyone, my name is Matus Kirchmayer. I'm the CTO of Matsuko. My background experience is in 3D games industry and also online gaming industry. So that's more related with the network than anything else. And in Matsuko, we are doing holograms, real-time meetings, possible with just one single camera.
I haven't changed my role that I know from the last time that I said so. VP of Strategic Incubation. I've been in Microsoft for 22 years. Most of my career on incubating new technologies for the cloud. So I started with the cloud, developer cloud, as we call, so developer services in the cloud. Then I moved 8 years ago incubating the AI business in Microsoft. That was my role 8 years ago. And now I'm leading a new function that is broader than AI to incubate the next big businesses in Microsoft, one of them being actually the future of networking that I was covering today.
Very good. So what we want to understand first is how we see this demand coming. So I will ask the panelists, maybe starting with you, Matus, but how you see the demand coming, this application, which application is going to stretch really the network, and what is really important, what we saw from yesterday, maybe we start with Wi-Fi, is going to move cellular. How you see this step from basically a usage more at home towards maybe more mobility, right? So.
Yeah, so I think it's really about we are still staying, I will stay just in the metaverse 3D world. I would say that there's a lot of challenge with the amount of content, and thanks for the all-detailed presentation we've seen 1 hour ago, is that once we switch to the 3D, the content will just explode. For some simple reasons, everybody knows that the third dimension brings just an extra multiplication, or extra dimension, of course. But actually, while more importantly, if we start to scale, it scales cubically. So basically, cubically. So that's the big problem. So when we watch, I will just make a quick example. When we watch a video, it's of course very framed. It's one specific resolution, or if it's 2D frames, one after the other, being compressed over time. But if we go to an online game or online virtual world in metaverse, you can look everywhere around, so you don't have a clear frame, okay? It's everything around you, and there's a depth. So I work personally on the online game engines used in open world games. I was the technical lead and designing the whole architecture for the networking and streaming of open worlds, like in Assassin's Creed, and of course a very big one, which was Watch Dogs. And you cannot put that many data on a DVD anymore, nor a Blu-ray. It's just huge worlds, and you are there. You are not just watching. You are inside. It's immersive. And you can just walk or drive a car, and everything needs to be streamed, and that's so many data. So for me, metaverse will bring, just go back to the question, the data will really explode, and it's because of this third dimension of the metaverse. The second aspect, I would say, is the user experience. The demand is for much higher quality of the experience. So it's not only on the resolution, but I think there was so nice very good examples we've seen in the previous presentations about, let's say, the fluidity, for example. So to bring a really nice fluidity, you need to bring a much higher frame rate, so it requires a lot of data. In the average, it's much more data to stream. And on the other side, if you go back to the 5G question, you would expect the data everywhere. So it's not just the sitting experience being at home, watching Netflix passively, but you want to interact with it. you just want to walk in your city, and while you're traveling, you want to have access to all these crazy metaverse informations on like ad hoc. So this is everything that the 5G networks, for example, will be able to support. And for me, it's the combination, we mentioned it, a hybrid network. So it's Wi-Fi and 5G and all the combination that will see the same challenge.
So David, you have shown a very good use case with a kind of remote driving. From your point of view, what is going to be the most demanding type of application in the metaverse that will drive this network demand?
Yeah, I think there's a common pattern that we see in these applications, and the way that we look at it is so think of 2 dimensions in here, right? So you have one dimension, which is whether your application is very local, right? So it's in a very particular space that is going to happen, or whether the application is really very wide in the range. So you have a broad reach geographically, right? Then you have another axis where you measure how much real time do you need in that interaction, in that experience. You have real time interaction, or you have non-real time interactions. So for us, in our opinion, the sweet spot for this new generation of compute plus networking is on the top half, right? So think of a very real-time, high demands of real-time interactivity with a broad range, right? With a quite broad access to it, right? So that is where we're seeing a lot of interest from the industry and developers on creating these new experiences, right? So we saw one, of course, the metaverse. Looking at the metaverse, just in the metaverse, you can talk of many scenarios. The way that I like to think of, at least to categorize those scenarios in the metaverse, is of course the consumer metaverse with Meta doing fantastic things, right? But then you have things like the enterprise metaverse. We will see also new experiences of, for example, real-time communications being enabled by the metaverse, right? Or yours is a great example of that, right? Or we have then even more specific metaverses like the industrial metaverse, where we're seeing a lot of interest on these highly distributed, very complex operations in areas like manufacturing. This is an easy one, right? Remote operations of vehicle, but think of even more complex operations on remote facilities or highly distributed facilities. Think of big facilities, airports, oil rigs, etc., that we're seeing an evolution for. These were the typical examples that we were using all the time for things like 5G. We're seeing a huge demand of evolving that into a more intelligent kind of application that is network aware. Right?
Okay. I'm going to make an open question maybe to you three guys, Chris, Matus, and David. I mean, we saw a bit of everything in terms of bandwidth demand and latency. So 100 mega per user, 150, very low latency, 10 milliseconds, 15 milliseconds. From your point of view, what are going to be like the key references in terms of bandwidth and latency? We'll have to meet the KPIs of Francois, basically. What are we talking about? So I don't know, Chris, if you want to, or Matus, or...
So I think it's very good that we had this presentation about the quality of experience. So we developers, we can compress as much as we want, but at some point to really get to be able to bring the service or the product or to as many people. But at some point, the user will not be happy with the resolution because it's too blurry, with the fluidity because it's going to lag. So we have no other choice to look for the other side, like how much bandwidth can I get to actually satisfy the user? And it's always this battle on both fronts. And at the time, I can just very quickly jump back, in 20 years back, working on these online games, we had not all these services. So we've been really programming on the packet level. We've been managing everything, and it was how it really worked. I wish we would have all these kind of possibilities as we have today with how to work with the network and to look more on spending months optimizing the bandwidth, rather looking of the possibilities how to bring the highest bandwidth possible, the best latency, the jitter to the end user, and looking for the different services that can enable this. So this is, I think, how this domain changed. So for us, it's definitely something that we use a lot. For the holographic communication, I will tell maybe more about the concrete numbers. But of course, for example, the latency and jitter is absolutely, absolutely crucial for the end user experience, because what people want is for the latency to have a interactive, real person in front of them, not feeling that delay. It's all about immersiveness, feeling of the presence of you. Any slight delay, people are much more sensitive compared to the video conferencing calls.
Yeah. And from Meta, what is your point of view on this?
Yeah, I think you make a good point about the metrics are, I think, metrics that we're all familiar with. Latency, packet loss, jitter, throughput. I think what's changing is perhaps the consistency and reliability of those metrics is becoming more important. We see this in particular, we do a lot of work with Wi-Fi networks, and what we're seeing is that, at P50, median through the day, Wi-Fi is great. P99, when you really need it to work, is that's when the problems start to come in. And that's particularly relevant for real-time in-person communication use cases that only become more important as you transition towards metaverse, more immersive experiences. And that drives a new way of thinking about how we think about quality of service, and as we heard earlier in the presentations as well, how that relates to quality of experience as well. And as these use cases and applications start to develop, I think it's going to be interesting to see what are the quality of experience metrics that get developed alongside them, and how can we start to correlate between the two? How can we start to extrapolate for a given quality of experience? What's the quality of service requirement that's going to underpin that?
Really good. We are a bit late, but I would like to ask a last question to David. Maybe it's from a network point of view, what we can do basically to support all these strong requirements towards us. So.
Yeah, so I think there are basically two things that we can do in terms of enabling capabilities. The first one is the telco edge. So we can bring those components from the XR applications or metaverse applications that are specifically processing data, for instance, the hologram processing, reconstruction, etc., into the edge inside the network. In that sense, of course, we can reduce latency, but not only reduce latency by means of reducing the number of interconnection hops that we may have. We could provide a more stable connection and also more throughput if needed, right? And the second thing that we can do is in terms of all those things, or several things, in fact, that we can do to optimize the pure connectivity. We have seen some examples today and in the past days. But yeah, the first thing, for instance, is to use the QoD API to provide priority in the network, in the traffic handling. But also we could separate resources from our network, radio resources, which are, by the way, the most scarce, and allocate them to a specific slice that maybe we can dedicate to XR. So we may end up having an XR slice, right? And finally, not only we can do things that impact directly on how the network handles traffic, but as well to provide information about how it is the link, what is the performance, what is the link conditions, and feedback that into applications so the applications can adapt, right? So in summary, enablers, edge, slicing, open gateway APIs, and that translates into the NEF, right, in the network. That's the present.
Okay, thanks. So we are over time, I think, a bit, no, Xinli? I propose to take one question from the audience to the panel. Anybody wants to ask a question to these guys? Yeah, Francois.
I forgot your name, but
David.
David, quality of experience or quality of service in networks. IETF has started to work 20 years ago in different diffsers and prioritization, and it looks like still under development.
Yeah, but that's precisely the point, that we cannot guarantee things in radio networks, right? So that's the tricky thing about it. And the only way of somehow securing those requirements is by insurance, by securing resources and take them apart from the rest of the public, let's say. That's where slicing takes a part in, that we can separate those resources and dedicate for special things like XR. Because DSCP that you mentioned, right, is priority. This is what we call it in 5G, 5CIs or QCIs in 4G. And the mechanism has limitations, let's say, right? It depends much on the load conditions, but has no effect on your signal, power, your distance to the tower. These kind of things cannot have an effect, really. So it's very tricky, yeah. But we are on it.
Glad to hear that. A more coordinated and centralized approach.
Yeah.
Okay, thanks a lot, everybody. So it's time, I think, to conclude a bit about the session. So maybe, Xinli, if you want to come with me, maybe to close the breakouts. I think it has been a lot of work. We kicked off last year, same moment, right, in October.
Yes.
And it's such amazing all what we have done. So it's thanks to all the experts working in MRN. And I think we have some key next steps for this year to continue, like doing some real testing based on the framework, keep on the use cases, building usage of API. So I think it's going to be a lot of activities in the groups that we'll be defining after Fyuz, this year, and reprioritize a bit everything.
Yeah, we talked a lot about enabling technology, but we didn't mention, actually, we have a subgroup in the MRN PG that really is focused on enabling technology that will enable metaverse in the future and look into different services. And we welcome you to join us to work not only in QS, QE, measurement framework, definitions, not only in communication services, which was presented yesterday, but also in the enabling technology.
Yeah.
If I may, actually, I can introduce Cesar. He sits there. He is the lead of the group. You want to say a few words?
Yeah, thank you, Xinli. So as he's saying, I'm representative for that subgroup in the metaverse-ready networks. And right now, so we are just starting to work with the guys on which are those needs that we are having for those use cases, and try to find work items that we will be developing in the coming months. So yeah, thank you.
Yeah.
Thank you.
So let's go for it. Let's find the
go for it.
mechanisms that are going to make it happen. So
Yeah.
Thanks everybody for joining us.
Thank you for staying late.
Thanks to the panel.